One of the most commonly used exponential functions is compound interest. So what happens with compound interest is you're given a formula, A equals P. Now A is the balance of what you're talking about, whether it's a savings account or a credit card account, something like that. That's your balance. P stands for your principal amount. So if you're looking at, you deposit $1,000, that would be your principal amount. So this is how much the original amount that you have in your account. And then you're going to take that times. Now think about it though, before I say that, your original amount, think about that. That's what we're used to being as our y-intercept, which is the original amount. So it makes sense that that's what it'd be. 1 plus, and you'll notice this looks like a growth because it's 1 plus. And then the rate that we're going to have, instead of just being an R, we're actually going to have R over N. So R stands for our rate in decimal form. So if it was 3%, then it would be 0.03. And then N would be the number of times it's compounded in a year. So if it's monthly, then N would be 12. And so what it's doing is it's breaking down that 3% into a monthly kind of basis. Instead of 3% all at one time, it's going to be a 12th of that each time. And then that's going to be to the N times T power. N is still the number of times in a year, and T is the number of times or number of years it's going to be. So let's look at an example to understand that more. So again, our formula is A equals P times 1 plus R over N to the NT. And let's just say that we deposit $100. That means P is going to be $100. Okay, then we have 1 plus R, let's say our rate, it's 3% interest, so we'll put a 0.03 in for R. And that's going to be monthly, so N is going to be 12. That means also that N on the exponent is 12. And let's say we're going to find out how much is this going to be after 20 years. So we'll put a 20 there. And now it's just a matter of us calculating this correctly. So we always want to simplify what's inside there first. So we have 100 times, and now we have to take 0.03 and divide it by 12. Then we're going to take that and add 1 to it. So we get 1.003. You know what? I need to change my calculator. Hold on. So instead of 1.03, my calculator was stuck on just 3 decimals, so it rounded for me. So instead, I want it to be 100 times 1.0025. And then 12 times 20 would be 240. And then I have to take and raise that to the exponent. So 1.0025 raised to the 240th exponent. And so that'll be 100 times, and it's like 1.82075 and so on. But don't round it off yet. Keep that on your calculator and then take that times 100. Do not round until you get to the very, very end of a problem. And so it comes out to be 182.075. And since this is money, we're going to talk about $182.08 is going to be our balance after 20 years. So you see it actually doesn't gain all that much in 20 years, but it is only a 3% annual interest rate.